So imagine, right, when we talk two-dimensional, that's areas, and three-dimensional is volume. So imagine you have an original shape. In this case, we're going to talk about a box, but it could be a sphere, it could be a cone, it could be a cylinder, anything that has 3 dimensions, okay? And imagine for a minute that we are creating a new object, right? And so basically every dimension is going to be changed by a factor of k, right? So this new, if you look at the height here, this will be 3k. The width will be 2k, 2 times k. And the length here would be 5 times k. So every dimension is taken from the original. This is an enlargement, correct? It could be a reduction, right? I'm just going to talk about enlargement for now. Everything has been affected by k. So you right now do a mental game. Let's say if k was 2. So you're doubling everything, right? So it'd be 3 times 2 is 6. 2 times 2, 4, 10, right? So imagine that k is technically a number, but I want you to see what k is doing, right? What that scale factor is doing. So determine the dimensions, length, width, and height of the prism. We've done that. So determine the surface area of each prism. So we're going to use this formula, okay? So follow along here. Surface area of the original would be 2 times 5 times 2, so length times width, plus 2 times length times height, so 5 times 2, plus 2 times width times height, which is 2 times 3. Sorry, I got that wrong, right? This is not 2. On Mondays and Fridays, you have to be extra careful with me because I make lots of mistakes on those days. So this one is 5 times 2 is 10, times 2 is 20. 5 times 3 is 15, times 2 is 30. 2 times 3 is 6, times 2 is 12. And that gives us a total of 62. 62 squared centimeters. Now, I'm going to cut this. So I saved some space here on purpose. I tried to make it concise. Surface area of the new shape would be 2 times, what's going to happen? What's my length and my width? It's 5k times 2k. What is going on here? Next, I have length and height, so it's 5k times 3k. Next, we're not going to do this down the road, okay? This just to show you why I'm going to make a conclusion in a bit. 2 times 2k times 3k. This is probably where YouTube is going to be like, your teacher is talking gibberish. Would you like me to translate, right? That's probably what's going to happen. 2 times, so what can we do in this bracket? What's 5 times 2? That's 10, we know that, right? What's k times k? K squared. Plus 2 times 5 times 3, so you can multiply the numbers, that's 15. K times k is k squared again. Plus 2 times 3 is 6. K times k is k squared. Whoa, what's happening? Let's clean it up even more. 2 times 10 is 20, and k squared just stays there. Plus 2 times 15 is 30, k squared just stays there. 2 times 6 is 12, and k squared just stays there. How many k squares do I have? Well, there's 20 k squares plus 30k squares plus 12k squares. 20, 30, 12 gave us 62, right? 20, 30, 12, you've got 62k squared. Oh, what's happening there? So how much bigger, if this is the original, how much bigger is the new shape? You would have to say k squared times bigger, times larger. Not just k, but k squared times larger. What are you saying, Mr. Dirksen? Well, what did we do? The mental game was doubling, right? So we went from 3 to 6, 2 to 4, 5 to 10, right? Technically. So, but you cannot say that the areas will just be 2 times larger. You cannot say that. It will be k squared times larger. What's 2 squared? 4, right? So the area is actually going to be 4 times larger, the new area. Okay. So that's one thing I want you to remember, that when you're doing areas, we no longer just say k times larger, it's k squared times larger. Okay. Let me do this part. Just highlight the 62 so that stands out. Okay. Therefore, new surface area is k squared larger. I don't know, Mr. Dirksen. I think I should have skipped today. I don't know. All right, so this is my conclusion. Based on this fact, okay, that k squared is going to be surface area of the diagram divided by surface area of, what's the wording here? Diagram and actual. Thank you. That's version number 1. Version number 2, what do you think? K squared is going to be surface area of new, whatever new shape you're creating, divided by surface area of original. Yes. Aren't you excited about this one? I am. Anyways, that's that, okay? Mr. Dirksen, when will I know that it's k squared? Like, what is going to give it away? The units, okay? So if you know both of these as a number and there's a centimeter squared, a yard squared, inches squared, anything like that, oh, I need to make sure k has a power of 2 attached to it, okay? If you don't do it, you'll miss the boat, okay? You don't want to miss the boat. Guess what? Volume. What's the volume of the original? The volume of the OG. Okay? Some of you know that one. You appreciate that. What's 5 times 2 times 3? 5 times 2 is 10. Times 3 is 30. If you could just... Mr. Richard, your camera's off. I know. I'm not that famous that I have a camera following me yet. Okay, it's coming. What do you think the new volume will be? How much larger will the new volume be? Earlier it was k squared times the original, right? What do you think it's going to be now? K cubed. K cubed. And the reason being is that, right, all 3 dimensions are affected. So let's do volume of the new. It's going to be length times width times height. 5 times 2 is 10, times 3 is 30. So whenever you have a bunch of things, expressions multiplying, numbers multiply each other, okay? And all the variables that are alike multiply each other, but you just say k cubed. I'm going to use a different color for this one. 30. I'm going to highlight the 30s. Therefore, new volume is k cubed larger. One thing I want you to know is that the new is not always going to be larger. Sometimes it could be smaller. Okay? You can actually reduce it by k cubed. That's okay. We're going to go either way here. But here we go. You ready? K cubed. You're going to use k cubed if it's the volume of the diagram over the volume of the actual. Why do you give us two formulas? Just stick to one. I'm telling you, the wording is important. Otherwise, you're going to put the numbers in the wrong places, and that's not good. Yeah. This one? Therefore, new volume is k cubed larger.
Yeah. K cubed is equal to, in the box.
Yeah, here. K cubed, volume of diagram, volume of actual.
Yeah.
Or k cubed is volume of the new shape, volume of the original. You're welcome. Okay, this is where things get a little complicated. Listen carefully. These are formulas, right? The question will give you 2 out of the 3 things that are there. So let's say they give you the volume of both shapes. How would you find k? How would you just get rid of that cube there? What do you need to do to both sides when there's a cubed? You need to cube root both sides, okay? What about if it's k squared? Square root both sides. Okay, so you only root if you know both of these, right? If you don't do the root. You're like, what are you talking about? You'll see in a bit. You see what I'm talking about in a bit. So we're going to skip a few questions here. I'm going to take you to 34. I think my pages are off. I made changes to it, so I gotta make sure I'm all right here. Ice cream. That's what I'm thinking of. 37. Sorry about that. Okay. So we're going to start using this terminology now that before we didn't have to square root, we didn't have to cube root. Now it's going to change. Okay? You ready? Make sure you put distractions away. Using the scale factor to determine 2D and 3D values. Okay? So you're going to follow along really carefully. An ice cream shop is making a smaller cone for smaller children. So this is the original, and we're making a replica. So this is the, if this is the original and you're making a replica, what should I call this? Original and new, right? Yeah. Just making sure I get my terminology right. Determine the scale factor that was used to create the smaller cone. Can I do that right now? As is? Do I have enough information to come up with a scale factor? You do. What's this called in a circle? Yeah, diameter and diameter. You have both diameters. Do I need to worry about squared or cubes here? No. A bunch of giveaways. It's a linear dimension. And what are the units in? It's just inches, right? There's no squared inches, no cubic inches, right? That's just it. So we got to just go, K is, I'm going to use new over original. Okay, so new is 1.77 inches, and the original is 2.5 inches. Inches cancel out, so that's nice, right? We don't have to convert. Let's see what our calculator does here. I'm going to go 1.77 divided by 2.5. Math, fraction. it does basically just multiply both by 100, okay? 177 over 250. Let's turn that into a decimal just to make sure we don't forget. It actually is a finite decimal, so I'm going to use all decimals there. Or you multiply that by 100, you get 70.8%. This is overkill. You don't need to do this. It didn't ask in all three formats, but I'm showing you so you don't forget. Here's where things change. Folks, once you have your scale factor, once you determined what each of the dimensions have been changed by to get the new one, this does not change. K stays the same. You've determined it, you're done, okay? So don't be finding new things here. B, determine the amount of waffle dough required to make the original cone. It's asking for surface area because it's waffle dough. Because it's surface area, you're going to think K what? Squared is equal to surface area of the new over surface area of the original. My camera job is not good today. Sorry about that. There we go. So now plug in what you know. Do we know K? Yes, Mr. Erickson. Where is it? It's right up here. We already know what that is. That's going to be inserted here. So let's do that. What's missing right now? Squared. Yes. So do this. Right? Yeah. What do we know? Which one of these two do we know? We got to go back to our, this is the surface area of the original, correct? The original shape is right here, so that matches. We don't know that one, so this is our X. Do we know the surface area of the new? Yes. 10.15 squared inches. This right there is a dead giveaway. The squared inches should have reminded you, oh, I need to make sure I square this thing. Because Mr. Dirksen did this long, ugly thing where I need to square it, right? Yes, so that's another reminder. I might highlight that. Like if you see squared, you better put a square on your scale factor. Because that's to do this right, you need to do that. Okay, so watch what I'm going to do here. I'm going to square both of these numbers on this side because I want to get rid of that squared. So there's a number in it. Listen carefully. There's a number in it, so you got to go 177 x2. You get that. 31,329 over 250 x2. You get a big number. Don't worry about it. You have a calculator that's very powerful. Okay. On the other side, it's 10.15 squared inches and x. Please don't be squaring the 10.15. The 10.15 doesn't need to be squared. Just the unit, it's already squared, by the way. The inches, that's the only one that has a square, and that's fine. So how are you going to find x now? Right? You cross multiply and you divide. So whatever you get, if it's a decimal, doesn't matter. Just plug it in and go. Okay? So I'm going to go 1015 times. I have the 62,500 on my screen, so I'm just going to copy paste. I'm going to divide it by 31,329, and there it is, 20.25. Okay, it rounds to 25. Squared inches, right? I'm just going to say that's good enough. So that's my final answer. Question. What if we had used this as our scale factor? instead of the fraction. Would it still have worked? Yes, so I'll show you real quick. What's 0.708 squared? You get that, okay? So you would have had that here over 1. So it's basically 10, 15 times 1, right? You would multiply times 1 and then divide by whatever I just got. You get the same answer. So if you get a decimal, not a problem at all, you get the same answer. Make sure you just use all decimals. That's the key here for this to work out for you. Next, determine the amount of ice cream the smaller cone can hold. We're talking volume, right? When you fill something, that's volume. I'm going to say it's volume, so it's k cubed, volume of new, volume of original. What do I need to do? Do I know k? Yes. Okay, thank you. See, I'm even doing my student voices. Cubed. He's just weird. 10, 15, no, wrong. What do I know? I need the volume. I know the volume of the original, right? Yeah. Where's the, so that number goes right down here. Very important. And what are my units in? Cubic inches. Oh, cubic inches. Is this thing cubed? Yes, it is. Okay, good. Good. Okay, so this is where this calculator, I'm going to call this y. If you ask why, I'm going to say, well, why not, right? 24.54 cubic inches. Let's cube this thing. Do you remember how to do that? Maybe not. I may not have shown you. 177, if you look up here for a moment so that we can clarify this, there's a hat button right there. My pencil is like above the division sign. That hat button is the exponent, the power button. So I press that, and then I press 3 and hit enter. That's what I get when I cube things. 554, 5233. If you draw blank, you can also do this. Watch, 177 times 177 times 177. Like it's you do whatever works best. 250 to the power of 3 is that. Okay, now once you cube it, the power, the exponent goes, okay, no longer needed. That's the extra step you need to watch out for. Now what? I go to the side of the variable, I start with a number, cross multiply and divide. Easy. Five, 5233 divided by that big number there. That's my bank account balance. Yeah. Okay, 24.54 times divided by, so I get 8.71 cubic inches. Wait a minute, does it make sense that it's less than the original in this case? Does it make sense? Yeah, it's a smaller cone, less ice cream, okay? Yeah. There we go. I think we're getting somewhere. Did we use the root at all? Did we do cube root or square root? Why not? Because we knew the scale factor all along, okay? So that's where things are going to change. Page 38. At the top. I'm going to take a 1-minute water break. Can you read it and see if you can see actually if you would know what to do in this scenario? Okay. Okay, so Coca-Cola made a new larger pop can, as if there wasn't enough sugar in the regular one. But anyways, the original can is able to hold 355 milliliters and requires 322.57 squared centimeters of aluminum to produce, while the larger one is able to hold 500 milliliters. I just want you to know that when it's holding something, it's a capacity, right? Capacity, which is the equivalent of volume, right? You're thinking of volume, how much something can hold. So sometimes it's just going to be without the diagrams. It's like just a word problem. But most of you said I need visuals, right? I like visuals, so I'm giving you a visual here. So this is the original, and this is the new. I'm going to use original new here because it's not a picture of something. You're making a replica, right? Or a replica or a different version of the original. So all this information, so we know the height of the original, we know the surface area, and we know the volume. Of the new one, we don't know the height, we don't know the surface area, but we do know the volume. And that's where the key lies here. We know, okay, we know both volumes, right? So that, you know how I used to have the diameter of both or the height of both, right? Now I know the volume of both. So I need to use that to come up with my scale factor, because it's asking determine the scale factor. If I know volume, I need to think of what? K what? Cubed. Yeah, volume of new, volume of original. Now be very careful what you do here. Do I know what K is? Like, can I put in a number for K right now? I don't know what it is, so it stays that way. Do I know both of these? The answer is yes. Volume of new is 500 mLs. It's the same as cubic centimeters, but we're not going to go there. We don't need to worry about that. Volume of the original, 355 mLs. Guess what's going to happen to the units? Conveniently cancel out. All right, so what do I need to do now? Like, K is unknown, right? When K is not known, you need to take the root. So we're going to take the root, cube root that is, of the left side and the cube root of the right side. I will make a note later on this. Basically, the cube root cancels out with the exponent of 3. And on the other side, I'm going to leave it like this for now. Let's do 500 divided by 355. Let's just do what's inside the root. You get that, right? 1.4. I'm just going to write down the first couple of numbers. I'm going to say this continues. And now we're going to take the cube root. Do you remember how to get the cube root that I show you? What button do I press? Press math. For root, to take the root, you want to press math. Unless you find a different way, like you guys, students always surprise me, they find shortcuts. So if you find a shortcut, please let me know. Okay. Cube root, then you go up and then just copy paste the previous answer right into it, hit enter, and that is your final answer, 1.12. Let's see if we can turn that into a fraction. So what's that process? Math, enter, it automatically takes your previous answer. It cannot do it, just cannot do it. So even the calculator has its limitations. Oh, it wants a fraction. It wants it in the 3 format, so I'm not going to circle anything here. What I'm going to do is I'm going to multiply this number by 100, and I'm going to state as a fraction. And what I'm going to tell you to do is, you can go 1.12 over 1. That's silly, right? And then just multiply both by 100. Why by 100? Because I want that decimal to shift over 2 places. So it's 112 over 100. And you can reduce that one. I'm not, you know what, it's probably not going to happen. If you can't do it as a fraction, I'm not going to worry about it, okay? Does this scale factor change after this? Once we know it, do we need to figure it out again? No, now you know K. Now it's back to what we did before. I'm going to just take you back. Once you have K, we used it everywhere else, okay, to solve for something else. Don't square root anymore, don't cube root anymore, you're done, okay? So I'll make a note here. Note, I'm going to highlight this note. Only do this or this if K is unknown and you know surface area or volumes, okay? That's the only time you would be square rooting. If you, for example, knew both heights, please do not root whatsoever. It's going to take a bit of practice for us to get that. Okay. Can I ask you to try B and C? I'm just going to ask you to give that a try before I do it. You can look back at the previous question to help you out. Okay? If it's asking for how much aluminum is required, what are we thinking of? Aluminum is what makes this thing, so it's surface area. Okay? So try it. Look at the previous question to help you out. Aluminum required. So follow along, even if you forget, let's say you forget aluminum required a surface area of new, surface area of original, right? You're like, you forget the square. I'm making a mistake now on purpose, right? So you can't say you made a mistake. So what do you know? The surface area of the original, correct? Is 3. It's frozen. Just let it go, right? There you go. Thank you. Thank you for letting me know. Sorry, I'm making a mistake. I'm not going K squared. I'm just doing this right now. And then you fill in what you know. Surface area of the original is 322.57 squared centimeters. At that point, you should be like, oh yeah, this should have a 2 on it, right? It's very important. And this is my unknown. Do I know what K is? I actually do. So that is, which one should I use, Mr. Dirksen? Which one should I use? I will use this one right here. 1.12 squared, just like that. Can I use all decimals? Can I go back and use all decimals? Absolutely, but because this is a B part, you can use your rounded answer here, okay? Now we square it. Just square it. And so that's 1.2544. You can put a 1 underneath, why not? Some of you might think that's silly, right? That's okay. My kids think that at home as well. Okay. 322.57 times my previous answer. So it's 404.63 centimeters squared. I know I didn't show the work there. I apologize. That's that. Okay. You had to square your scale factors because we're dealing with squared units. Okay. And last but not least, determine the height. What are we thinking? Linear, squared, or cubic? Linear. Yeah, it's just the height. It's just like you can actually measure the height. So this is just K is equal to height of new, height of original. What's K? 1.12. What's the height of the new one? The larger can, we don't know what that is. But the original has a height of 12.2 centimeters. See that? Centimeters? Technically, there's an exponent of 1 there. So if you want to put an exponent of 1 there, be my guest. You don't have to. So it's multiply, divide, right? Multiply, divide. So x is equal to 12.2 times 1.12 divided by 1. Why would I do that? No one knows. And this is my answer there. Okay? So I'm going to ask you to try, just trying to see here, 39 to 42. But, hold on. If there's a table, I'm going to make it optional. So if you're doing the table, like I'll show you what I mean. Once you write this down, make sure you write it down. Don't just be like, oh yeah, I know. Right? Write down 39 to 42 on this page. I'll show you what I mean by a table. If you, for example, get to this part, it's a little overwhelming. I will show you how to do this one on Monday. So if you get to this one, you can try it, but you don't have to do a table. I want you to do the problems. Like if you have a problem there, try to solve that. Okay, so all the way to 42. That is it for today. Thank you, guys.